I guess I'm going to begin. It's 2 o'clock. We got a couple of people rolling in, but I think we're probably, anyone who's not here is going to be heading home by now. My name is Rich Allen. I'm going to be talking about containers today. Officially, we're going to be talking about bringing containers to production, some container overview technologies. I think a lot of us are using them locally and in development, but bringing containers to production can be a little more challenging, and there's quite a few strategies that you can go about depending on what your needs are and everything. So about myself, my name is Rich Allen. I'm the lead system developer and continuous integration engineer at Pixel. I got started with Drupal in 2009, the tail end of Drupal 5, but I sort of got my Drupal chops largely in Drupal 6 and 7 and now 8. From a need, I started transitioning a lot into the ops role. We needed sysadmins and we were doing more complicated things, and I happened to enjoy learning those types of things. So I've been doing ops for now 4 or 5 years-ish. I do a lot of ATO, stigging, that type of work for DoD and other clients. I wouldn't be here today if it wasn't, I have to give a shout out to my company, Pixel. A lot of time has been spent on this, not just in writing the presentation, but spending time learning these technologies, understanding what's appropriate for our clients, what's appropriate for us as a growing organization. It's very helpful to have that type of learning, and I wouldn't be here if it wasn't for Pixel. Pixel is a digital agency. They support everything from HHS to .mil. We do a bit of nonprofit and for-profit work. We do a lot of work, tools for the job, correct tools for the job, PHP, Ruby. We do quite a bit of Node. We play with Python and Go in the background in dev environments, getting ready for some more complicated things. The majority of our projects do feature Drupal, Drupal 8 as a CMS. We really believe it's the most powerful CMS on the planet. Lots of features, lots of security, good stuff. There's very few cases where Drupal isn't a great CMS. I'm done with the plugs, I swear. So today, here's sort of the meat of our discussion. It's not a super technical discussion. I sort of geared it for people who are very technical, looking to sort of get to production, and people who want to understand what their developers are trying to convince them to do. So it's just a very high-level overview. We're not going to get into the specifics. There's hundreds of hours of learning involved in all of these technologies. You won't be able to learn all of them at once or become an expert in all of them at once. It's very challenging, and there's, it's imposter syndrome all over the place. There's a lot of very complex technology here, and it's going to take several years to learn. So yes, we're going to be talking architecting a solution appropriate at hand. We all build a lot of Drupal sites. We're going to talk about when Kubernetes is appropriate, when it's not, when we should be talking about Elastic Beanstalk versus a very simple single EC2 type device. We're going to talk about, so prepackaged platforms, Docker Run and Compose, Elastic Beanstalk. We'll talk about Nomad, Docker Swarm, ECS, something like Rancher, EKS, Kubernetes, Fargate, and then we'll talk about Kubernetes and Mesos on your bare hardware and why that's not for you. So now that we all know what's sort of going on, we're going to get ready to throw everything onto production and just go at it, right? I promise this is my only cheesy little meme joke in the entire presentation, but I had to do at least one of them. There's a lot of things to consider when you're talking about going to production. We know that containers solve a lot of problems. They also present their own problems, different challenges. I think overall containers are definitely the future of deployments, at least for the next 3 years, until something cool and new comes out, just like it always happens. But for the most part, we're going to use them to solve issues, but they bring up difficult things. So first thing I usually like to ask, is our company proficient enough in Docker? The reality is so running Docker on your local machine is a lot different than we have a device that's live now, and I have to troubleshoot it. You need to be very confident. You need to be confident in your strategies, and you probably want more than one developer available in your organization who can handle even the simplest of strategies. A lot of organizations have very capable back-end devs who can log in and use SSH and use the command line to install a couple of tools, but they're not familiar with a lot of bash. They haven't done a lot of automation, and there's some things behind there that you really need to know and be comfortable with. You should be sort of promoting within your organization proper DevOps culture to be sort of sharing these types of things throughout your entire ops team and not creating one bottleneck. It's a recipe for a very complex and nasty disaster if you want to run your own hosting. And I will say that, especially if you're looking at these strategies, you tend to be looking at high availability type, very robust hosting strategies when a platform won't be working. My example is, so how do I import a bad database backup from a bad deployment? The command that I show up there right now, that's the actual command. That's considerably more complex than a normal Drush SQLC. You sort of have to know about how shell piping and redirection works. And that's how you sort of have to know small little things that'll catch you like that. Have we talked about a logging strategy? So a lot of times when we spin up just an EC2 device, it's a permanent device and it lives there all the time. We just have to worry about log rotation and things of that nature. It's very simple. When you're talking about Dockerized deployments, you're talking about ephemeral devices, which will be spun up and destroyed multiple times during the day. Uptime on a single device is no longer a metric that we consider valid for the stability of our service. When you're talking about rolling deployments, you may have 4, 5, 10,000 webheads depending on your needs. So have we come up with that logging strategy, a distributed logging strategy, so we can see our entire application infrastructure at a single time? Are we building lightweight images that are quick to deploy? Excellent, that came up on my screen and not there. So that doesn't sound like a big thing in development. I know we hand someone a brand new image and we're like, don't worry, it only takes this the first time to download it and then every time afterwards it's much quicker. That doesn't work when you're in a live environment. If you're talking about just Drupal core with its installed dependencies, you're talking about 400 megabytes, 500 megabytes from just core and the vendor library. If you quickly add in a couple of React applications for decoupled, you can talk about 1.5 GB sized images. The use case that I like to use for this, so let's say we have a rolling deployment. We have an auto-scaling event and we need to create a brand new EC2 device to spin up a new webhead to handle our demand. So the steps to that go, we spin up an EC2 device, we install Docker, and then we download our brand new Docker image. It takes a significant amount of time to download a 1.5 GB Docker image, and then so what can happen is EC2 is now reporting, and it's reporting healthy, so your load balancer starts checking your health checks, it's reporting it healthy, and then all of a sudden you have bad instances and you end up in this vicious little loop where new instances are being spun up, but they're not in production quickly enough, so they get taken down and you can't create new instances. I didn't have this happen to me about 4 months ago, so trust me, it does happen. So the last thing that we talk about, are we running security and vulnerability scans on our base images? I think this has been highlighted really recently. We can't necessarily trust open source repositories to a T. We need to be trusting on CVEs and running scanning security software on these images, because while everything is a faster pace, there's a lot more people involved and a lot more commits. So we all know SSL had its issues the other day, or the other year, a year ago. We know that Homebrew, just recently, someone was able to basically pose as a contributor to the entire network and start making malicious commits within about 30 minutes of social engineering. And these are guys who run, packaging management. They're smart, intelligent guys, but every chain has intelligent people, but every chain has its weak link. And so you need to be running security and vulnerability on these, I think, a lot more than running your own software. It's not necessarily just provided by Ubuntu anymore at this point, and you have to be a little more looking for those types of things. So I just want to go over sort of the last questions I want to ask before we start talking about a containerized deployment. Does my application have a need outside a prepackaged platform? In general, when there's a prepackaged platform like Acquia or platform.sh that will support your needs and is specifically tailored to your product, the company spending millions of dollars on it and has several engineering teams is generally going to do a better and more efficient, cost-efficient job than you. I know we all like to be, great engineers and do everything. A lot of times it's just cheaper to spend $60 a month. A lot of the infrastructure that we'll be talking here takes weeks worth of time in the more simple cases and months worth of time. And if you translate your server costs to engineering time, it doesn't scale well. So you should have an application that really merits doing custom architecture. For FedRAMP and basic services and everything, we really love Acquia and then platform.sh for our non-federal clients. Not to plug them, I'm not associated with them, but they really do offer very flexible services. They offer high availability, logging, your development workflow, and backup and restoration, essentially packaged in a box for less than $100 a month. It's a really good value when you consider what they're offering for it. So now that I've been sort of a Debbie Downer and told all of you to not really do this all the time and stick with the simple stuff, let's get with the fun, more complex stuff that you might be considering about doing. The first solution I really want to talk to is probably the most simple solution to get to production. It's simply Docker run and Docker compose commands. It's really great. It's low barrier to entry. You're already using this on your local and development environments at this point. And essentially you don't need changes. You don't need to make large infrastructure changes. You don't necessarily have to get into infrastructure as a code and Terraform. So it's very simple and very easy to get into. It's also very easy to troubleshoot. You're not dealing with a sort of very abstract system with hundreds of containers. You're dealing with a single EC2 device running Docker, running a few containers on that local machine. You can do a Docker PS, see what commands are actually available, and then start doing your normal troubleshooting, and the workflow is very similar if you're hosting just a typical EC2 device. What it makes up or what it is in simple, we talk about it's not really scalable. You can set this up in a high availability infrastructure if you set up, multi-availability zone auto-scaling groups using CloudFormation or something like that on AWS. Typically, there's lower barrier to entries than setting up an auto-scaling EC2 to group and more native solutions. So if you really are talking about high availability, if you're making this solution high availability, you're probably making extra work for yourself, and you should be talking about a different type of technology. There's a lot more resource management on the EC2 device, and then you have limited resource management from the Docker Run and Docker Compose. It's just not designed to essentially be an enterprise type hosting environment. It's definitely meant to be a more local or single instance type. If Amazon goes down for 4 hours a year, it's not the end of the world if my blog is not up. I don't need to be spending hundreds of dollars on infrastructure a month to make sure that my article gets that extra read at the end of the day. It's not very manageable after a couple of containers, especially if you have an interesting scaling strategy. It's going to involve just a lot of manual things, a lot of not reproducible code. And so if you're talking about large infrastructure, it's really not appropriate. It's more of we're going to try our first Docker deployments, or we're going to do this on development environment and get our feet wet. It's a great strategy for that, but it's not very long-term manageable. Just a little note, the newest version of Docker and Docker Compose, while I haven't actively tried this out yet, it does actually, when you are running it, you can spin up a Kubernetes cluster, and it'll essentially take your Docker Compose file, and that'll translate it into a Kubernetes type environment, which is very helpful for learning Kubernetes, I'm hearing, because you can sort of reverse engineer it and see how a Docker Compose turns into a Kubernetes type environment. That's also an important note later when I start talking about Docker Cloud and Docker Swarm. So that's pretty much it for Docker Run and Compose. I would say the next step that you can sort of talk about is an Amazon specific service, and it's Elastic Beanstalk. Elastic Beanstalk comes in multiple flavors. A lot of them are just the platform variant flavors where you get an EC2 device with Ruby or PHP installed. They also have a Docker flavor, and this supports a multi-container Docker flavor, essentially meaning EC2 is sort of relegated to spinning up resources in the background and becoming a load balancer. The nice thing about this solution is you still are just running EC2 instances in the background, and they're still just loading up Docker Run, and you can still do that easy low barrier to entry troubleshooting where you can just log onto a single device, and it's a little bit easier to handle than a large networked thing. It's nice that you have supporting services. So one of the challenges I will talk about a little bit later is your persistence layer, or MySQL. This thing really would love me to join the network. Okay. Sorry. So it's very nice when you have services like CloudWatch and relational database services. Like I said, log rotation is difficult, right? You want to find where your logs are from your 3 different devices at once. You don't want to have to be SSH in the 3 logs to find out what's going wrong. And so these are nice. You don't have to build up these services. You don't have to run your own MySQL layer. And those are challenging things that we'll talk a little bit more about in Kubernetes and why nobody's really doing them. Elastic Beanstalk is probably your easiest way to do a high availability, multi-availability zone infrastructure. Amazon handles 90% of it for you. If you can set up your Docker environment and you know how to implement the basics of Amazon services, you'll need to do something like an Elastic file system and a relational database service to support a Drupal site. But at the end of the day, it's very low barrier to entry, and it just spins up EC2 instances with your Docker containers running when they boot. So it's not much more complicated than that. It's another nice, very low barrier to entry. It is more challenging though than setting up a single Docker instance on your own. There is Amazon configuration, and that horror story that I sort of listed earlier before was sort of Elastic Beanstalk not being clever enough about auto-scaling events. So there are limitations here. It is an older solution. This is sort of invented or created 3 or 4 years ago, and it's sort of fallen out of favor to some of the newer services just because it's not really a cloud native solution. It originally started as a PHP, Ruby, Python native type solution on top of EC2. Another problem here is vendor lock-in. There's nothing really like Amazon or Elastic Beanstalk out there right now. Anything you do in here is going to be very specific to EC2 instances and EC2 configuration. It's not really easy to do a multi-cloud type, super high availability instance with this technology. I would say the biggest con of this is the process of configuring your EC2 instances to get them set up with the dependencies and build spec is probably the hardest part of this entire thing, and it's not necessarily the Docker stuff. If you're comfortable running Docker Compose and Docker Run and troubleshooting those, you're not going to struggle with Docker in this particular case. You're going to struggle with Amazon and their web services. AWS can sometimes be like Drupal. You can do everything, and because of that, nothing is really documented very specifically, and it's not a lot of recipes out there. You're sort of left to your own devices. So beyond that, we have Hashicorp and their program called Nomad. And I put a special note in there for Consul and Vault because we start off with Nomad. It's very similar to Docker Compose. Hashicorp is an open source infrastructure company who has an open source infrastructure as code community. They have many technologies like Terraform, Nomad, Consul, and Vault. And you can essentially build up your own cloud using these technologies. They're very powerful. I wouldn't recommend you do that though, because someone already has, and it's probably better at it than you are at this point. It uses HCL, which in my humble opinion is a little bit easier to work with than YAML. It's JSON based, so you don't deal with like a lot of indentations and improper tabbing breaking your code. Call me a hater, we'll argue for 3 hours afterwards. I prefer the JSON or the HCL over YAML, so I view that as a pro. Your mileage may vary. It's also a great simple solution for single container applications, so like a node application. This is a really great simple solution. It also scales really well to a more complex solution, kind of. I say this because Nomad, in a very open source spirit, does a single thing. It is only a runtime container. It will only run your containers. It will not do secret discovery. It will not do environment variables for you. It will not do service discovery for you. It will not do any of that for you, and you have to involve Vault, Consul, and Terraform to get that type of infrastructure. If you want to write your own custom infrastructure, it's a great way to do it, and this is probably the #1 community supported way to do it. And you'll probably end up using Terraform in some of these other containers, but not necessarily Nomad. Nomad is if you have a very specific reason. It can be low barrier to entry, but it's very hard to scale because you have to know an entire ecosystem of technologies. Great. So the next one I wanted to talk about is Docker Swarm. And there's a note about this. There is a difference between Docker, the technology, and Docker Inc., the company, and this is important. Docker Inc.'s version of container orchestration. They were sort of the first ones to hit the market. The administration and CLI is very similar to Docker Compose. So it uses the same Docker Compose files. Essentially what you do is you set up an agent on your target devices, and you can do this on one or multiple devices, and you can do this on a single cloud or multi-cloud if you'd like. And then you use a client agent to essentially join your Docker Compose to your swarm, and so this is how they handle orchestration there. Some of the pros is, again, it's very native to Docker Run and Docker Compose. You won't find anything crazy new there. So it's a very low barrier to entry and easy to troubleshoot, and it's very well documented. It gives you a very nice control panel out of the box. So logging, metrics about performance, up and down nodes, those types of things that you might have to pay for or build, or in using a more complex solution. So those are very nice. As far as I'm aware, and I'm not an expert on Docker Swarm, it's not really available outside of cloud.docker.com, the enterprise who's essentially supporting that cloud. As far as I know, they're the only ones really offering that support. And it creates a lot of vendor lock-in, a whole ton of vendor lock-in. The reason this is very important is because there's rumor mills all around the place, but the reality is that most of the community has chosen a different solution at this point. And while right now this technology is very well supported, it's not necessarily supported by the community. It's being supported in an open source sense, backed by Docker Inc. financially. Rumor mills abound. I might be wrong. In 2 years, they might be the most successful Fortune 500 in the world, but there are rumors that they are not in good financial health, and the community is sort of what we're seeing with the move to Kubernetes. It would be a risky to be all in on this strategy. It's very good to explore with and learn how these container orchestration technologies work, but I wouldn't be putting at this point, in my opinion, any infrastructure on Docker Swarm. So it's good to learn, but again, too many rumors, and there's a lot of support around Kubernetes at this point, which we'll discuss, and it really is just a more enterprise grade tool, and a lot less vendor specific. So you've been warned. A note here. We're going to cover now Elastic Container Service and EC2. Microsoft also has their container service, and so we'll cover the specifics on Amazon just because I'm more familiar with it. But a lot of these services are available on other platform providers, and I know we all like to laugh at Microsoft. There's a strong argument right now that Microsoft is really sort of taking a lot of improvements with their cloud, and they're catching up very rapidly to Amazon. I wouldn't laugh at them so much. They are supporting open source technologies now, and if you are doing a mix of open source plus closed source Windows technologies being federal clients, Microsoft Azure is actually a really great solution, and you shouldn't be afraid of using Microsoft there. They have very comparable and also very both in price and technologies. We're going to talk about AWS though, because everyone knows about them. Elastic Container Service is commonly called Docker as a Service. It's very nice because it is built into AWS's cloud. You do have this support such as container registries built in, and that includes built-in container registry authentication, which if you've ever used Amazon Cloud at this point, it's kind of a pain in the butt when you want to do a Docker push. It's about 12 different steps and commands if you have an MFA token and you're approaching this. If you've ever done it, you've got to set 4 or 5 different environment variables. You've got to get a session login, then you've got to get a specific Docker login. You got to set all those variables, and then you can finally start pushing your image. So it takes a lot of the headache of coding that into your various builds, and so it's a very attractive offer there. There's less EC2 configuration here. So in Elastic Beanstalk, we're talking about EC2 configuration on a per instance basis. When we talk about EC2 configuration here, we're talking about essentially an EC2 backed, EC2 is backing our entire infrastructure. So we have one or two EC2 devices distributed over multiple regions, and then we have essentially 5 or 6 containers running on all of these with the server sort of sitting in the background. So essentially you just end up choosing I need 16 gigabytes and 4 hours of compute time for this application to be running on a constant basis. You're not necessarily picking out individual nodes. I need a T2 mini for every webhead. I need a T2 large for all of my RDS instances and that type of configuration. So that's lessened. It is a cloud native solution. However, the problem with it is backed by EC2, and so provisioning can be very slow. If you do have to spin up a new cluster and you run out of resources or you want to do something, it can take as much as 5 or 6 minutes depending on what type of cluster and the availability and load that Amazon's under right now. And it's very slow to wait for deployments, and sometimes that's a challenge, and it makes deployments go very hard. So you want to make sure that it is what it is. It's a great technology. I would use this over Elastic Beanstalk today. It's far more simple and a more cloud native solution. There are challenges though. You are still configuring EC2 a little bit. Again, you get the vendor lock-in. I'm not as worried about this. I don't think AWS is going anywhere anytime soon. Again, I could be wrong on that one, but it seems like they're around for a little while. Unless you're really concerned about running multi-cloud environments, or you want to be able to move your application, if Amazon jacks up their prices, ECS is a great solution. You can do high availability against different availability zones. My goodness. And it's much simpler than Elastic Beanstalk. So there's the vendor lock-in, but I would take it anyway. You'll do the same thing with Microsoft Azure. They'll be similar, but it is what it is. When you're doing that on their cloud, it's not a cloud native solution. In this solution, it is heavily geared toward Amazon services. So if you do have to configure outside resources and you don't necessarily want to use a relational database service, you have to use something else. For whatever reason, it can just be a little extra work and tricky to get these working with them. You have to do a lot of extra network configuration, make sure you have bastions coming into your network. And if you're doing a completely cloud native solution, AWS, as they tend to do, make sure that they take care of all of that for you. The next thing I want to talk about is opinionated orchestration packages. I'll take just a moment to say that we're sort of getting out of sort of running individual containers here, and we're getting into Kubernetes and running a platform of containers. I just want to take a step back and stop. Like, if you're getting into Kubernetes, it's very challenging. It's a multi-container system on a very arbitrary network design. There's a lot of things that go on in the background that you have to know about, like service discovery, secrets, and you have to know how to configure those things. I think even one of the challenges that most people run into is, how do I serve SSL over my cluster? If you haven't talked about setting up Let's Encrypt using an ingress in Kubernetes, and if that sounds like gibberish to you, you're probably not at the point where you should be looking at these solutions. And it would help you to not go crazy later on when you're trying to troubleshoot these solutions. Make sure that you have several members on staff that know how to do this. The other thing as well, if you're talking about Kubernetes service, you're really starting to talk about really high availability here and wanting to run multi-cloud type solutions. There are Kubernetes certification exams. They're not bad like most certification exams. I'm Security Plus certified, but it's a pretty terrible exam and doesn't really tell you anything. The Kubernetes exams are actually practicals. And if you can get through the Kubernetes exams for them, you're probably ready to start experimenting with these types of clusters. Rancher, OpenShift, and CoreOS are the big popular examples of sort of opinionated orchestration packages built on Kubernetes. So they have Kubernetes-based services, discoveries, tools, and their own custom open source infrastructure built into them, and some tooling around that to simplify the Kubernetes experience. They provide opinionated workflows and services. So you don't have to, so they have logs, they have dashboards, they have the ability to create a persistent volume for your MySQL volumes and everything like that. It's very nice, and I think this is a sweet spot for a lot of small to medium-sized organizations, and I know there's actually some medium to large-sized federal organizations starting to build their cloud off of some of these technologies. So we've started to see them out in the wild, and it would benefit you and your business development team to have a little information about where these clouds are and what technologies they're doing. So we'll talk a little more about Kubernetes, but essentially at the end of the day, they're just Kubernetes packages. They do have advanced, albeit opinionated deployments. You can do canary and blue-green deployments, so we're getting to the fancy stuff where I only deploy to 10% of my fleet at the time because I want to test whether this change is affecting users in a bad way. I wait 4 hours, and then once I see no reports from our 10%, we roll it out to the rest of the fleet. So we can do things like round-robin load balancing, saying 50% of our users go to this server, 50% go to that. It gets crazy, and you can start writing your own. You probably don't need to, honestly, if you're talking about, unless you're talking about selling, tens of thousands of users on your interactive application. For the most part, we're really talking about infrastructure that is complex, and you probably don't need these types of deployments. You can learn about them, and they are good for more complex applications. We are starting to see them if you're sort of at the top, in the bleeding edge there. A shout out to OpenShift. They were bought up by Red Hat Enterprise Linux 2 years ago. And OpenShift, if you're working with government and RHEL STIG'd images, is a really strong offering if you're using the RHEL workflow. If you're not, I would probably look at other technologies. It's very opinionated about using Red Hat products, shockingly. RHEL is really great, though, to use. They offer quick support, a lot of vendor patching and support, and so OpenShift is a great alternative if you know you're going to be doing a lot of stigging and federal ATOs and that type of work. You don't need to configure your own supporting services. They tend to have images and SQL servers and Postgres servers built into these types of solutions because persistence is hard. Most organizations are not doing their own data persistence layers. The typical consensus around the community is running your own MySQL container is more effort than it's worth. Just use RDS or Microsoft relational database services. Again, they put millions of dollars into these services. you're not going to do better than them, and they're going to be fairly cheap. Unless you're really doing a lot of load and a lot of demand, the costs just don't scale up against engineering time and trying to figure out how to do this and then being able to support it for multiple years. Very little vendor lock-in here. So you are sort of using a tool set and an opinionated build workflow. However, at the end of the day, they all are using YAML files for Kubernetes. You can export all those, and you could apply all these YAML files to another Kubernetes cluster and upgrade to a sort of more mature type solution. You will be sort of a little bit tied into some of the tooling that they offer around like secret discovery and, oh, I've set this API key, how do I recover it, and IAM and roles and things like that. But for the most part, there's very little vendor lock-in. You could, in theory, do a multi-cloud solution with this. It might be a little challenging. You might want to go with bare Kubernetes services to do it a little easier, but it's certainly up in the air and doable. All right, 10 minutes. The next thing, we're sort of getting into Kubernetes as a service. This is what I would consider sort of the top tier of what 99.9% of companies are going to be looking into. If you're starting to look into Kubernetes on bare metals and everything like that, which we'll talk about, you're probably wrong and setting yourself up for disaster and pain points. The big three are Amazon EKS, Elastic Kubernetes Service, Google Cloud Platform, Google Kubernetes Engine, and the Azure Kubernetes Service. Against tradition, Google is actually the first to market here. And so GKE is generally considered the most stable and easy to use and feature complete implementation at this point. AKS and EKS are fairly new. They just came out into general availability 3 to 6 months ago, depending on the service. And while initial reports are that they're fairly stable, it's definitely still a bleeding edge project and their product, and they're still working those edge cases out. I would expect that within 6 months, all three of these services will be an excellent way of running a multi-cloud, super high availability type application. If you're going to do it today, save yourself the headache and go with Amazon for now. There's another reason for that is that Amazon has another cool service called Fargate, which we'll talk about. Lots of flexibility out of any of these services. You're running Kubernetes as a service, you can essentially run any type of infrastructure that you would need outside of air-gapped, secure, top secret type environments. There's no reason this is way overkill for running just a Drupal website. Your Drupal website should be tied into an e-commerce system. You should be selling several thousand, items a second, and you should really need at this point high availability. You can experiment with it. If you're running, a smaller application which you think has room to grow, it's a good way to grow into it. But Kubernetes is complex. Don't let anyone ever tell you that it's simple. They offer certifications out there because there's a lot of people claiming they can do Kubernetes, but it's really just sort of on their locals, and they're not really running it at scale and don't really have the proper knowledge around it. It's a challenging technology, but it's also really powerful. Supporting services, container registries, CloudWatch, and RDS, you still get these if you use Kubernetes as a service, which is really nice. So you get the flexibility of running container orchestration, but you don't have to write persistent layers. You don't necessarily have to run, if I'm not confident in running an Elasticsearch service because I just don't have the system admins, I can run those using Amazon services. So it provides you a lot of flexibility unless you're trying to do truly multi-cloud type solutions. Continuing on Kubernetes on the service, so we talk about persistent volumes. You could run your own persistent volumes, and when I say that, that means spinning up the latest version of MySQL and essentially running database on EBS disks or whatever the service is offering. The majority of people, and we're talking about even small startups with funding, are not doing this. Again, backing up in a repeatable, test and proven way when you're talking about Kubernetes and high availability becomes critical. You're talking about transactional data at this point. People's orders and money gets involved. And if you lose someone's $1,000 order, get ready for a phone call. So at this point when you're talking about this scale, do you really think that you could store, maybe we're running 100 different images and we're running master, slave, MySQL over multiple availability zones? Is your organization really equipped to monitor, backup, and most importantly, test those backups? Or do you want to end up sort of like GitLab where, oops, we didn't test our backups and we don't have a really strong backup strategy? Even to really strong technical companies who make great products like GitLab, it just proves the difficulty of running these types of services and the critical nature here. And so that's why a lot of professionals recommend that you do not run your own SQL and persistence layer unless you have a very good reason to. Amazon's not going to lose your backups, and they're especially not going to lose your backups if they're stored in multiple S3 buckets across different availability zones. It's not going to happen, and you're more likely to screw it up and lose someone's order or whatever you're doing, at Kubernetes at this scale at this point. Kubernetes as a service is very nice. There's less cluster management. So instead of talking about, again, EC2 instances, you say, I need a T1 large in AZ West, AZ East, and AZ Northwest. It spins up those instances, it installs Kubernetes on there, and then you just get a single nice entry point, and you log in and do your Kubernetes, you log in, and you essentially have your cluster available to you. So there's really a lot of the best of everything in Kubernetes as a service, and this is probably the most appropriate solution for people who are very confident on Docker, container, and orchestration, have a high degree of maturity, and are really looking for like 24/7 support, and essentially running a small application which is going to have users, a dedicated ops team. This is the sort of type of stuff that I think that you're probably going to want to make sure you have before you're running Kubernetes in production. If you want to sort of take that risk beforehand and not necessarily have that support, good luck. You're a little braver than I, and I'm an engineer, talking a lot of crazy stuff to my boss. I got my pop-up again, so I have to take a break. The last thing about Kubernetes as a service is this is probably, if you really need, actual .999 type uptime, Kubernetes as a service is probably what you want to be looking for if you can't use another service that's provided for you. You can do this very simple with Terraform. You can have multi-cloud, so you can be running your application on a Kubernetes cluster in Azure and Google Cloud Compute or Google Cloud Platform and AWS. So if AWS and 2 of their regions go down, your load balancer shuts off and you still have 2 regions up. The odds of AWS, Azure, and Google going down at the same time, someone's cut a line somewhere in the Atlantic and the world's on fire. Business would stop for a lot of people at that point, and I think the odds of that are happening. We don't have more high availability beyond that. If you're running on 3 clouds, thumbs up, you got it. You can put that third 9 on the end of that dot. Fargate. So Fargate's brand new too. It's general availability about 2 months ago when I released EKS. Fargate's very cool. So Fargate is basically Elastic Container Service plus Kubernetes service minus the cluster resource management. So essentially AWS Fargate lets you assign either an EC2 task or a Kubernetes task and service and command and login, and you don't have to define the cluster management behind it. Essentially, all of their instances and all of their clients who are running on this infrastructure, AWS has a fleet of EC2 instances waiting on standby. Pricing is going up and down and fluctuating just like the stock market, and that's sort of how they do it. It's truly on-demand pricing, and it's probably outside of Lambda and functions as a service because serverless doesn't exist. It's probably the most resource and cost-effective way to run high availability architecture if you're not looking for multi-cloud type solutions. Fargate is very much a very specific AWS technology. Azure and Google don't have anything comparable to this as of yet, and I haven't heard anything is on the horizon. So you are very much locked into Amazon with this. But it's very nice. So instead of ever defining any EC2 instance anywhere, you define your application. I need 0.5 CPUs of compute time and 128 megabytes for this container. You push it up and the containers run in about 3 or 4 seconds. There's no EC2 building, no waiting there. Everything is loaded into it because you're on Elastic Container Registry. So everything is very quick, snappy, and you aren't paying for any resources that you're not using. It's on demand and will fluctuate with your infrastructure. So it's a very cool solution. You do lock yourself in AWS, but as I said, you could lock yourself into a worse partner than AWS. In general, even if you lock yourself into something like this, you can probably redo it into Kubernetes if you feel like you need a multi-cloud solution later on. Everything is sort of your fleet in the background, some stuff that I missed. There are still logical separations, so you can set up your applications in different clusters, so you can still use IAM roles and have proper separations of concerns and privileged access and everything like that. And yeah, that's AWS Fargate. Very cool, very new though, so use at your own risk. It's for experimentation for another 4 or 5 months until it's true general availability. Last slide, last technology here. Running your own Kubernetes or Apache Mesos. And most people don't even know what Apache Mesos is because it's not as cool and it's not a cool buzzword. The first question you have to ask yourself is why? Am I trying to run a data center? A follow-up question is, why am I trying to run a data center? Probably not a good idea, especially since the federal government has tried to do this for 20, 30 so years, has not done a good job, and is now sort of catching the back end of the train to basically everyone's now trying to create a cloud platform, everyone's trying to get FedRAMP compliance with containers, and very few people successfully have done this. I doubt anyone in this room should be running Mesos or Kubernetes on bare metals. It's not an appropriate solution for all, but the most custom infrastructure, air-gapped security, top secret type infrastructure, and then I don't think that working at those levels you're going to necessarily get the DoD to go on this newfangled technology. It's harder even on NIPRNet before you're on SIPRNet. So there's very little use case in the federal government, unfortunately, for this, i.e. if you're thinking about this, you're probably wrong. Come talk to me afterwards and I'll tell you why you're wrong, but you're probably wrong. So seriously, have a good reason for this. The reasons that you might have it cost at a very, very high scale. You're actually trying to run a data center and it being profitable, and you're competing on efficiencies of pennies and being able to beat your competitor out by a couple of pennies. This is good. You can run your own hardware. You don't necessarily have to pay the upcharge that AWS and Azure do for having their nice stable services. Compliance. We all work with ATOs and varying levels of different federal entities in the containerization race. Some people just are not going to let you do your own containers. So you would look at something like Mesos. So what Mesos is, in case people don't know, and I sort of skipped over that, Mesos is a very highly unopinionated, very complex way of doing not just container orchestration, but also virtual machine and hardware. So if you have a lot of legacy apps, for some reason Docker's not approved by your organization, but you have very serious concerns, but there's no timeline or any of those, you might be talking about Mesos. Documentation, you're not going to find a Medium blog explaining with a nice little tutorial about how to use the command line and get everything set up on your thing. You're on your own and you're dealing with the most intelligent of developers and really truly enterprise top tier systems and network administrators. So it's a complex technology. Kubernetes on bare metal is also the same. Setting up your own Kubernetes service, even on your own hardware, or necessarily even if you're spinning up like an EC2 instance and running your own Kubernetes instance, just not as a service, or you're actually spinning it up on your own VMs and racks inside of your data center, it's challenging. At this point, you probably are having an entire organization within your organization, an entire department of ops players, and people who are going to be helping. You should have ops integration on every single one of your feature teams and that type of level of maturity. There's probably, at this point, 1,000 companies in the world who would have a strong reason for running their own Kubernetes on their own hardware, or even Kubernetes on top of EC2 and something like that. There's very little reason. The Kubernetes as a service are very cost efficient, and it's probably going to be very cost efficient until you're talking about real large economies of scale. I think we're sort of finishing up sort of what I want to cover. I got behind on my slides, but I think I covered everything in those bullet points, and we're wrapping up with about 2 minutes left for me to go. So I covered all of those. Just want to thank everyone for listening to me rant for 45 minutes. If you have any questions, I'm going to be sticking around for a little while down here until they kick me out for the next presenter. I just want to thank Bixel again, second to last plug. I learned a lot of this in my past 2 or 3 years as an employee there, and even though we don't do all of this in production, it allows us as a company as a whole to grow and understand what is for us and what is not. So allow your developers to do cool stuff every once in a while. Don't let us go like free reign though, we'll break you. Thanks everyone. Questions before I stop recording?
Simple virtual machine, and I want to play with the Docker. What should I use, like a Docker machine or any other?
Is it on OS X?
I'm sorry?
Is it on a MacBook?
No, it's like on the, let's say, on somewhere in the cloud.
So you're running Docker in the cloud, and you're just trying to get an instance spun up?
Yeah.
Sorry, and what was the question again? I'm just trying to figure it all out.
What is the best tool for it? Is it like Docker machine or Docker Compose?
I prefer Docker, especially during a learning time. Docker Compose does a little bit behind the background. It's up to you. I don't think that there's one better than the other. I think doing Docker run is a little more complex, but it's not that much more, and I think you're learning what's actually going on instead of running like a Docker Compose exec with the container name. Like you actually know that like you'll use the -- name tag. So me being a little bit of a purist, I would say take off the training wheels as early as possible and go with the native Docker and Docker machine.
A very specific question. So let's say I have like a MySQL container run, and I want somewhere to map the data to the real hard disk. Is it possible to do?
Yeah, so what I would do is when you write, so he's asking for the video presenter, I didn't do this, how to do database persistence sort of on disks and make sure that you actually persist it. The way that I would probably do that as a simple strategy is just back up your EBS disks. So when MySQL writes data, instead of using the database dump, you can just back up the entire var MySQL directory, which will have the raw binary of that data in time. And you can grab a disk of that, and I would just back up EC2 disks. Then what you can do is you can just mount different or EBS disks to different containers as needed. However, that doesn't work it's difficult in a SQL situation because you're dealing with read, write, master slave type situations. So again, that's why high availability is available at the click of a button for about $40 a month with relational database service. But yeah, you would do it, I think, with EBS block mounting. There might be more enterprise-like strategies at the high scale. Unfortunately, it's an intermediate talk. Anything else?
What does opinionated mean in this context?
Just their own tooling chains. So like so I would guess like Kubernetes as a service in Google is also opinionated to some degree. But if you log into like RHEL has the best example of this. So RHEL wants you to use a very specific build order. OpenShift contains a multi-image build, which is set up to be sort of an enterprise grade. So there's sort of step 1, add this container layer onto it. Step 2, add this container layer onto it. Step 3, deal with your RHEL licensing. It's very opinionated in that sense. And if you don't necessarily have the need to do a very complex build, so I'm just building a Drupal website, I just need to run my tests, it can sometimes be challenging because you have to make sure you comply with how they want those builds. I found that the least opinionated of all of them in my exploration was Rancher. They sort of try and be very cloud agnostic and really just sort of service agnostic and just allow you to run containers using Helm, which is a Kubernetes plugin if you're familiar, and provide sort of recipes how to actually build out typical applications. So like Bitnomni has a Drupal Helm chart that you could deploy within Rancher. I would say that's the least opinionated, but also providing logging, console access, and documentation. RHEL's the most opinionated. So like, go check out the RHEL PHP image. And if you check out the RHEL PHP image and you see how you want to alter the image, you'll find if you need to add your own customizations, there's a lot more steps. They want scripts in certain areas, and they want you to do certain types of actions in certain steps. Follow. Oh, I thought you were raising your hand again.
What's your opinion on CoreOS?
My opinion on CoreOS. It has a lot of support. I haven't used it myself. It is sort of the first to market, and I do see, I think, more of newer people talking about Rancher. I think CoreOS, though, is very trusted even at an enterprise level. I don't necessarily know the pros and cons. I haven't used it enough, so I won't speak to those. But I would say it's very trusted in the community and probably a safe choice. I know that there's a lot of Fortune 500s running on CoreOS type infrastructure. So it's a safe bet. No one ever went wrong with Microsoft, right? You're probably the same way with CoreOS. Yes?
Hey, I know you used to be Ansible, Vagrant, all that stuff.
Yes.
The transition to Docker.
Yes.
Did you just drop Vagrant VirtualBox? Did you keep using Ansible? Do you no longer use Ansible at all? Is it
I don't use Ansible at all anymore, but Ansible is actually very useful in some of these strategies, especially when you start getting into more complex continuous integration and development. Ansible is very nice in certain use cases. I do use a lot less of it though, and I try and do the majority of work in my Docker run files. As far as that transition, I went cold turkey. I also did have the help sort of after I learned quite a bit on, so one of the technologies to learn very nice on are Lando, Consul, which are sort of intermediary. They're container-based, but you still have that virtual machine layer of help. And then the WADB, Drupal for Docker stack, is a very excellent Drupal stack that we actually base our entire core scaffolding off of. So those are the tools that I learned to sort of get away from it. And so I'm a fairly experienced sysadmin. I've been doing it 4 or 5 years before then. It took me about 2 to 3 months before I felt comfortable to start asking money for training. I went to an 8-hour training, and that's really sort of when I started feeling comfortable bringing back and starting to implement Docker. It was sort of a 9-month turnaround from when I really cut attachments to virtual machine type stuff, and we now have Docker in production running over high availability. So it's going to be a little bit painful. Make sure you're experienced with it and you have a clear reason and strategy behind it. Don't do it on production early, but if you can cut the ties, Lando and Consul will really allow you to be still productive as a developer while learning some of the containerisms type deals, but they're training wheels. Get off of them as soon as you feel comfortable and you understand that every single Consul or Lando command is really just a Docker exec with a nice pretty wrapper around it. That's sort of what those instances do. They just add nice commands so you can have a Docker help and you know how to import a database so you don't become completely stuck in trying to I can't set up my local anymore, and I've been doing this for 10 years.
Thank you.
Anything else? Cool. Well, thank you very much for your time, and